GloVe in natural language processing. AI intermediate level. Introduction. In natural language processing, computers must convert words into numbers before they can analyze language. A simple method like bag of words can count words, but it does not understand relationships such as similar meanings, word associations, semantic patterns. To solve this, NLP uses word embeddings, where each word is represented as a dense numerical vector. One of the most important word embedding methods is GloVe. GloVe stands for Global Vectors for Word Representation. It is a model designed to learn word embeddings by analyzing how often words appear together in a large text corpus. GloVe became popular because it combines statistical word co-occurrence information, efficient vector learning, semantic relationship understanding. It helps machines understand language in a more meaningful way. What is GloVe? GloVe is a word embedding algorithm that creates dense vector representations of words using global word co-occurrence statistics. In simple terms, GloVe equals learning word meaning from how frequently words appear together in large text data. Example concept. Word co-occurrence patterns means vector representation. Example. King means 0.41 minus 0.22, 0.76. Queen means 0.39 minus 0.20, 0.79. Words that appear in similar contexts get similar vector representations. Why GloVe is important. Earlier methods like one-hot encoding and bag of words had major limitations. They could represent words numerically, but they could not capture meaning well. Example concept. Car and automobile means treated as unrelated in simple methods. But humans know these words are closely related. GloVe solves this by learning from the global statistical structure of language. Example concept. Words appearing in similar environments means similar vectors. This helps NLP systems better understand meaning and relationships between words. How GloVe works. GloVe learns word vectors using a co-occurrence matrix. A co-occurrence matrix records how often words appear near each other in text. Example concept. Large text corpus. Down pointing arrow. Count word co-occurrences. Down pointing arrow. Build matrix. Down pointing arrow. Learn vector representations. Example sentence. The cat sat on the mat. From many such sentences, GloVe learns which words frequently appear together. Instead of only looking at local context like some other models, GloVe uses global statistics across the entire corpus. This is why it is called global vectors. Co-occurrence matrix in GloVe. The main idea behind GloVe is the co-occurrence matrix. This matrix stores how often one word appears near another word. Example concept. Rows equals target words. Columns equals context words. Values equals frequency of co-occurrence. Example simplified matrix. Cat dog milk bark. Cat 0350. Dog 3014. Milk 5100. Bark 0400. From this information, GloVe learns meaningful embeddings. Global statistics in GloVe. The special strength of GloVe is that it uses global word relationships. Example concept. Entire corpus statistics means better semantic structure. Instead of only predicting nearby words one at a time, GloVe analyzes the whole co-occurrence structure. This allows it to capture broader semantic patterns. For example, ice means solid, cold, water. Steam means hot, gas, water. Because the relationships are learned globally, the vectors can capture these distinctions effectively. Vector representation in GloVe. Like other embedding methods, GloVe represents each word as a dense vector. Example concept. Word means numerical vector. Example. Dog means 0.21. 0.34, minus 0.17. Puppy means 0.24, 0.31, minus 0.15. Since these vectors are close in space, the model recognizes that the words are semantically related. This creates a vector space of meaning. Semantic relationships in GloVe. One of the most famous features of word embeddings is semantic vector arithmetic. GloVe can capture relationships such as king, man plus woman approximately equals queen. Another example, Paris, France plus Italy approximately equals Rome. This happens because the embedding space preserves many meaningful relationships between words. These vector relationships make GloVe very useful in NLP tasks. GloVe versus Word2Vec. GloVe and Word2Vec are both popular embedding models, but they learn differently. Word2Vec learns embeddings by predicting words from local context windows. Example concept: local context prediction means word vectors. GloVe learns embeddings using global co-occurrence counts across the entire corpus. Example concept: global co-occurrence statistics means word vectors. So the main difference is, Word2Vec focuses more on local prediction. GloVe focuses more on global statistical relationships. Both are powerful, but GloVe is especially known for its matrix-based statistical approach. GloVe training workflow. The general workflow of GloVe is: large text corpus, down pointing arrow, build word co-occurrence matrix, down pointing arrow, apply optimization algorithm, down pointing arrow, generate dense word vectors, down pointing arrow, use vectors in NLP tasks. These learned vectors can then be used in machine learning or deep learning systems. Example Python code. GloVe embeddings are often loaded from pre-trained files rather than trained from scratch in simple. Examples. Example code. Import NumPy as NP. Embeddings equals. With open. glove.6b.100d.txt. R. Encoding equals UTF-8. As F. For line in F. Values equals line. Split. Word equals values. 0. Vector equals NP. Array. Values. 1. D type equals float 32 inches. Embeddings. Word equals vector. Print. Embeddings. King. This example loads GloVe vectors from a pre-trained embedding file and prints the vector for the word king. Real-world applications of GloVe. GloVe embeddings are used in many NLP systems. Text classification. Representing words numerically for sentiment analysis. Spam detection. And topic classification. Search engines. Finding semantically related words and improving search relevance. Chatbots. Helping systems understand user input more meaningfully. Recommendation systems. Comparing text-based descriptions and preferences. Machine translation. Capturing language relationships to improve translation systems. Advantages of GloVe. GloVe has several important advantages. Advantages include: captures semantic relationships between words. Uses global statistical information from the corpus. Produces dense and meaningful word vectors. Often performs well on word similarity tasks. Useful for many machine learning and deep learning applications. Example concept. Global language patterns mean stronger word relationships. Challenges of GloVe. Although GloVe is powerful, it also has limitations. Challenges include: requires large text corpora for strong embeddings. Produces static embeddings. Same word gets the same vector in all contexts. Struggles with polysemy in older embedding methods. Example: bank means same vector for riverbank and financial bank. This is one reason why newer contextual models such as BERT became important. GloVe versus contextual embeddings. GloVe produces static embeddings. This means a word always has the same vector, no matter where it appears. Example concept. Same word means same vector every time. Example: bank, money, bank, riverside. In GloVe, both uses of bank usually share the same vector. Modern transformer models such as BERT, GPT, Roberta generate contextual embeddings, where the vector changes depending on sentence meaning. Example concept. Same word plus different sentence means different vector. Concepts learned from GloVe. Understanding GloVe helps learners understand. Checkmark how words can be represented as dense vectors. Checkmark how co-occurrence statistics help capture meaning. Checkmark how global corpus information improves embeddings. Checkmark how semantic relationships can appear in vector space. Checkmark how classic NLP embedding models work before transformers. GloVe is one of the most important classic techniques in NLP. Simple definition. GloVe, a word embedding algorithm that learns dense vector representations of words using global co-occurrence statistics from large text corpora. Final summary. GloVe is a powerful word embedding model in natural language processing that represents words as dense numerical vectors. Unlike simple text representations such as bag of words, GloVe captures semantic relationships by learning from global word co-occurrence statistics across a large corpus. It helps NLP systems understand similarity, association, and structure in language. GloVe has been widely used in text classification, search, chatbots, and other NLP applications. Although newer contextual models like BERT and GPT are now more advanced, GloVe remains a foundational concept for understanding how machines learn word meaning from text data.